Hello, I'm Clayton Stuffelbeam, PFR agronomist with Beck's Hybrids.
I'm Tony Utel. I'm the PFR technician out of the Effingham, Illinois facility.
Today we're going to talk about corn planters and the planter pass that you're going to make every single season. I think it's very critical to do a good job with your maintenance as a foundation, but also be patient on the first day you're going to be in the field. We're going to talk about corn planters from front to back, top to bottom, in depth on a lot of different scenarios with the corn planter. Before we get in depth, we are going to take a look back historically on the big planter innovations that have happened from 1960 on up to where we are today. So we're going to take a look here, and we're going to go starting in the 1960s. One of those notable innovations was the finger meter. It was actually designed in 1963 by a gentleman named Eugene Keaton. He designed it and then shortly sold that design to John Deere, where I found, for 50 cents a meter for the first 50,000 meters sold. So Eugene Keaton, at the time, made $25,000 for that finger meter design. We all know that the finger meter was utilized by many different companies throughout planter history. Very important innovation that happened in 1963. 1966, Dickie John was the first to have a planter monitor. And all that planter monitor at that time was going to tell you was if your planter was actually dropping seeds row by row. I don't even know if it was telling population back then, but that kind of set the stage for further innovations coming down the road. 1966, Alice Chalmers was trying to focus on no-till planters, kind of in an era where tillage was still a very big process for your farming operation. They were the first to utilize a fluted Coulter. Later on in the presentation, I'm probably going to tell you to take that Coulter off. 1968, the John Deere 1200 and 1300 series planters was the first series of planters to utilize that finger meter. John Deere might have made some upgrades, maybe some tune-ups from the initial design to where they started using it in 1968. Now in 1971, International Harvester could be credited with the first bulk fill planter. That planter was the IH Cyclo 400. A group of farmers actually designed that, and Case IH bought or purchased that design from those farmers. In 1974, Oliver came out with the Plant Air 5400. Previous to that planter, White had purchased Oliver. Not long after that planter was designed and released, that planter became a White planter with the same number designation. What was cool about that planter was it had a vacuum system on it, so it can get credited being the first vacuum planter at the meter level. However, it didn't use a common vacuum for the whole toolbar. It used an individual vacuum, row by row. It was an electronic vacuum, so it wasn't driven by PTO. The electrical current was created by a PTO generator, and then the current went row by row. So kind of a cool innovation back in 1964, and we see a lot of electronics happening again today. In 1974, one of the most important innovations I think we talk about is the design and the release of John Deere's Maxi-Merge row unit. It wasn't sold as a no-till planter until 1978 when they did some things different with that row unit. The reason I think this innovation was so important is we went from a planter that had runners and maybe one depth gauge wheel to a planter that had true V openers, a gauge wheel on both sides of those openers that were independent of each other, allowing us to walk that row unit along different planting conditions and keeping it engaged with the soil and creating a consistent seed trench. Whereas a runner wouldn't do that. It was hard to keep a consistent, well-formed seed trench. And then following those gauge wheels would be the true V closing wheels. Those assemblies we see today present on John Deere planters still, Kinsey planters, many other brands out there in the marketplace today are still kind of using this foundation for their design. Also in 1974, when that planter was released, kind of a cool mention here, John Deere also released the monotrol system up there in the upper right. That system allowed the planter operator to change his population on the fly. Kind of how a rotor in a combine changes speed. This worked the same way by bringing the employees together or spreading them apart back in 1974. So I thought that was pretty cool to find that. I found that in a planter brochure when that planter was released. Also in 74 and 75, Kinze came out with their rear fold and their 24-row planter. So they were the first to have a 24-row planter and really the first to have a well-folding planter in the marketplace. Coming into the 80s, in 1980, International Harvester did change the cycloplanter. Then we have the first designation of the early riser. The early riser, what you see today in the red unit behind me here, the Case IH 2000 row unit, following gauge wheels, leading and following disc openers, and a two-stage closing wheel system. Very similar to what we have today. Of course, today is more rugged and more robust, but we were starting to see that back in 1980. 1984, Kinze came out with our push units. And what that push unit allowed that planter to do was to do split row crops. So 30-inch rows in the back and then 15s when we engaged the fronts with that system. And it also allowed us to work on that planter much more easy and improved residue flow in no-till situations. And then in 85, they made that planter lift and rotate, making it really easy to work on at head level. 1985, John Deere improved the MaxiMerge 1s when they came out with the MaxiMerge 2s. A few things they improved upon were the gauge wheel adjustments, closing wheel adjustments, depth, and parallel arm assemblies, and downforce. That was the first year, or the first planter from John Deere that utilized a vacuum meter. In 1989, also cool here, Black Machine had a planter that could plant split row designation or fold out from a 15-foot planter out to a 30-foot planter utilizing the same row units, but having double width in corn as far as your total overall toolbar width. Coming into the 1990s, this is kind of the first decade we started to see aftermarket additions coming into the marketplace. In 1990, the Kinze brush meter was developed. Eugene Keaton and another individual had a part in the designing of the Kinze soybean brush meter. In 93 through 95, Martin was really the first company to offer something that was aftermarket, that being floating row cleaners and spike closing wheels. Today, there's a lot of different manufacturers and parts that we can add onto our planter, which we'll talk about. In 94, Eugene Keaton's back again. He designed the Keaton seed firmer. Precision Planting ended up buying that design off of him. His initial design used a cable, heavy cable, in the seed trench to ensure that seed was positioned at the bottom of the trench and stayed in the trench. 1996, John Deere went from the MaxiMerge 2s to the MaxiMerge Plus row units. This was the first row unit that John Deere offered that had easily adjustable downforce system, and it was more posed to work well in a no-till scenario. 2001, Kinze came out with a 3650. That was the first non-Case IH bulk fill planter in the marketplace. It did not utilize air. It worked completely different. My dad and I had one of those on our farm shortly after those planters were released. In 2005, John Deere went from the MaxiMerge Plus row units to the MaxiMerge XPs. The XPs featured a cast shank, so that was their first cast row unit. Pro drives, so we got rid of the chains and went to a cable, so we got rid of some components there, and then airbags for downforce. That airbag system wasn't automated. We'll get to that here pretty soon. In 2006, air clutches became a thing. a step I wish we could have skipped. They did fix a problem. In my area where I farm, we have a lot of point rows, a lot of irregular shaped fields. By doing this, it reduced the amount of interplanting that we were having in every field, but it also created some issues as far as keeping them clutches maintained. That was quite a job in keeping them working. Today, it's even hard to find parts for air clutches. In 2008, I often say this is probably the second most important innovation. Whether you've had a Precision Planting 2020 or not, it has affected your operation. The metrics that made you get out of the cab, singulation, population, spacing, good ride, downforce, a lot of things that made you a better planter operator. But if you didn't have one, this is where it affects you. It made the competition get better too. So today there's a lot of options out there, a lot of good options from other manufacturers that help you do a better job in the field at planting time. Also from Precision Planting in 2009, they come up with Air Force. It was the first automated air downforce system in the marketplace, and it featured lift and downforce. So back in 2009, we even had that notion in our head, hey, lift might be important. Coming into the mid-2000s, White released the 8936 planter on tracks in 2011. They were thinking big planters, big acres, some John Deere and Kinsey planters as well at that time frame, utilized very wide bunch of row units. Today, things have changed a little bit. Still some big planters out there, but we're more focused on high speed. 2013, Dawn released their hydraulic downforce system, the RFX. It was the first hydraulic downforce system, row by row, automated in the marketplace. 2013, Kinsey released their electric drive planter with their 4900. It was the first electric drive planter on the marketplace. However, John Deere and Precision Planting weren't far behind them. In 2014, Precision Planting was super busy that year, released multi-hybrid, V-Drives, which was their electric drive motor for V-sets, and then Speed Tube, their high-speed option, and Delta Force, their hydraulic individual row controlled automated downforce system that did offer lift and down. In 2014, John Deere released ExactEmerge. That was their high-speed offering. At the same time, the MaxiEmerge 5 row unit was released. We'll talk about that unit quite a bit today. In 2017, Case IH released the 2000 series early riser planter. So that's their newest row unit. It's behind me. Very robust and durable row unit. In 2017, AGCO purchased Precision Planting. It's hard to believe we're coming up on a decade here in a few years how long they've actually owned Precision Planting. Same goes with high speed. Over a decade now from when that technology was released. In 2019, Precision Planting came out with Furrow Force and Smart Depth. Now we're getting on to the latest few that have happened most recently. John Deere released ExactShot in 2023. We've got a considerable amount of data with ExactShot today from our on-farm research. It is a system that pairs with an ExactEmerge planter and applies fertilizer in the furrow on the seed only. In 2023, Kinsey released the 5000 series row unit. It has a higher focus on wear and adjustability and serviceability. Very heavy row unit. We'll talk about the parallel arm assemblies on that unit and the gauge wheels and other components that row unit has to offer today. In 2024, they took the 5000 series row unit and then they made a pusher option for narrow rows. So we finally got a heavy duty Kinsey option today. That 3000 series unit was getting pretty old. I'm happy to say they've got one today on a split row planter. Also in 24, the last two, Precision Planting released Cornerstone, their newest version of their row unit they're offering. The cool thing about it, it's got following gauge wheels. the only company to have following gauge wheels. Started in 1980 with that early riser Case IH row unit. It took this long to get following gauge wheels. I'm a believer that they can be better and offer less shock to the row unit with following gauge wheels as opposed to pushed gauge wheels. In 2024, John Deere came out with Furrow Vision. I believe it's commercially released today. Furrow Vision is going to give you a few things. It's a camera that's positioned in the trench. It's going to show you trench quality. We're going to talk about that. It's very important. Also going to talk about depth, probably furrow temperature, soil temp, residue in the trench, and a lot of other things that might help you become a better planter operator. We're going to get into maintenance here pretty quick. But before Tony comes up and starts talking about the maintenance items, there's one stat here. I robbed this from Precision Planting's winter conference a few years ago. From one of their surveys, 71% of growers believe their current planter is costing them yield. I'm one of those. I know coming into this planting season coming up, I'm going to have to take a look at my planter. I take it down to the studs every year, at least as far as the row unit goes. We're going to look at those components. I know what's costing me yield today. I know that we've got to take care of that coming into the planting season. So with that being said, Tony's going to come up here and we're going to start at the front of the row unit and work backwards.
That's exactly right, Clayton. So before we do that, let's talk about some units that we have with us here today. And so we have two John Deere ME5 row units. One over here, we would classify as needing rebuilt. This one here, we have rebuilt with some of the components that we're going to talk about here today. And so let's begin at the front with the parallel arms. These guys got to do a couple things for us. One, they've got to keep that chatter out of that row unit. That's going to cause that poor spacing there whenever we have that chatter in that row unit. And so what we're going to do is we're going to come to the back of this unit and we're going to lift up here around the closing tail and see if we have some play. If we get to having around 1/2 inch of play, we're going to want to look into some of these options. And what happens here is we have this mild steel arm and this hardened steel bushing. So this bushing is supposed to be the wear point in this, but because the bushing is harder than this mild steel arm, it either wears out the arm or it wears out the bolt inside of the arm. And so many of the options that we're going to talk about here today go to a bushing inside of a bushing design. So we have a harder pressed in outer bushing followed by a softer inner bushing. All right, let's talk about some OEM options on the market. Here with the John Deere option, if we go to our local John Deere dealership and get new arms, new bolts, new bushings, we're going to be looking at $366 per row. We do the same thing at the Kinsey dealership. For the Kinsey 2 and 3000 series row unit, we're going to be spending $172 per row. Same thing at the Case dealership with the 1200 row unit, we're going to be spending $254 per row. I ask that you guys keep those numbers in mind as we go through here. All right, let's get into our aftermarket solutions right here. And so first up, we have our Precision Planter Solutions or our PPS kit. There's really two options with this option right here. We can either buy the DIY kit, so we can buy this kit right here. We can remount our arms on our own planter. We can press those teardrop shaped bushings in and install them ourselves. Or, yeah, we would have to ream those out with that arm. Or we can buy the pre-made option right here or the pre-installed option, and we can buy their arms with their bushings already pressed into that arm as a complete kit right here. So for that DIY kit, we're going to be looking at $135 per row plus that $174 reamer. With that pre-installed kit, we're going to be in that $305 to $380 range right there with that $51 reamer. And now we are going to have to remount the W plate and the goalpost with those, but we're mostly going to be taking out the paint and a very, very little bit amount of metal. And so you see here, we do gain some wear width, 45% more wear width with this option because of that teardrop shaped bushing on the outside right there. All right, moving on. Our second aftermarket option is the Solid Rock Ag. And so these guys are doing things similar, but just a little bit different. Now they're refurbishing arms. So you place an order with them, they send you refurbished arms, and then you send your arms back to them for a core charge. And so that initial purchase is going to be $278 to $313 per row. Once you get those new arms installed, you send your arms back, they're going to send you back a $35 core for those arms. Once again, the Solid Rock Ag utilizing that bushing inside of a bushing design right here. All right, our third option is GBGI. Once again, all out of the same. You can see by this picture here, we have a hardened outer pressed in bushing right here, followed by a softer inner bushing right there. Once again, that comes with the appropriate hardware for that option right there, that properly shouldered bolt, fine threaded bolt as well. All right, then we have our precision planning Duraware option right here. Once again, that same bushing inside of a bushing design with that Duraware arm right there. That's going to run you $350 to $375 per row, depending upon make and model. All right, then we got the Kinsey 05 upgrade kit. And so this is going to be something that you can go down to your local Kinsey dealership and buy for that 3 and 4000 series row unit right here. And so that's going to be that same pressed in, harder outer bushing, followed by that softer inner bushing right there with that Kinsey 3 and 4000 compatibility, looking at $389 per row for that option. All right, the Bearing Force guys are doing things just a little bit different here. So up until this point, we've talked about a bushing inside of a bushing design. The folks at Bearing Force are doing things a little bit different. They're pressing in a sealed bearing inside that arm for that pivot point. And so, Clayton, would you like to speak to your experience with this arm just a little bit?
Yeah, we'll talk about the other arm as well, the Kinsey arm first. So I'm going to talk a lot today about our Kinsey 3660 that we have on our farm. The season coming up is the 13th or 14th season that we've ran that machine. So I've gone through at least 2 sets of factory arms in that time frame. I'm always shaking down the planter, checking the play. The last time I replaced arms, I did go to this 05 series upgrade kit for that 3660. The reason I picked this kit versus any others, I think any other kits are fine, nothing wrong with those. But if I need parts, I've got a Kinsey dealer right down the road, so it takes me no time to get them. I've ran 2 seasons on this arm currently. It's still as tight as the day that we installed it. The bushings are also oil impregnated. Now, if we go back to that Bearing Force slide, I was concerned, didn't really know if the bearings would hold side load. So planting around your inroads, your headlands, terraces, if that bearing was actually going to take the torque of the row unit when you're making your turns, because you're not always planting perfectly straight, how those bearings were going to hold up. So I purchased 1 row, I put it on the outside row unit of our planter, and I ran a season. This is that one of the upper arms off of that row. After 1 season, the bearings still seem really, really good. Walking into a new season, knowing that I may or may not need a parallel arm maintenance, this is a system that I would look into going forward, be low maintenance ahead of time. Our goal with this, Tony and I both agree that if we're going to replace parallel arm assemblies on our row unit, first we're going to start by throwing bushings at it. You know, if I can get 1 row of bushings, a cheap way, make it work, and that we eliminate our play, I'm going to go that route first. However, if you put the new bushings in, and we've still got that play, we're going to go to something else we have on the table here. That way in the future, our wear points become the bushings, not the arms themselves. So we don't get this recycle of recycling steel all the time. That's my goal here. I'm a guy, I come from a farm, that we keep our planters for a long time. We just keep working on them.
All right, so we look at all those options together here. We remember that OEM option down here in the very bottom right. In most cases, all of these aftermarket arms are a very, very similar price. So maybe we can spend less money or the same money and get us a long-term option like Clayton was talking about. All right, as we move back, let's talk about some disc openers. Now, this is a very, very important part of the row unit. These guys need to create and maintain that furrow for us. They need to be able to cut through residue and operate in the tough conditions that today's planting conditions demand of them. And so right here we have a chart with the planter brands and models right here, new spec and replace spec for all of those blades. Now, not only do we need to keep this diameter in mind, we also need to look at one more thing, and that's bevel. So you see here, we have a worn blade right here. It is measuring exactly 14 3/4 of an inch right there. But whenever we flip that around and compare that, this used blade to this new blade, we see the differences in the bevel right here. And so with that old blade, while it is technically in diameter spec, that bevel is disappearing. And as it continues to wear, it's going to disappear faster and faster. Therefore, we're going to be pressing a blunt edge into the soil right there. That could cause hairpinning of residue. That could cause some seed trench issues for us right here. And so Clayton, on his farm, looking ahead at the wear he knew he was going to put on in that coming season, decided to change these blades. All right, now that we have decided to replace those blades, what are we going to replace them with? There's a lot of different options on the market. We've got a few up here on the screen in the green, ranging from $26 all the way to $70 right here. And so there's a lot of different options on the market, and Clayton and I wanted to kind of quantify these blades to a certain extent. And so we ran a run out or a wobble test on them. Now keep in mind, this is not the gospel. This was only done on a couple blades, but we wanted to put some measurements to what we were seeing here. And so you can see the wobble differences in a lot of these, and we're going to get to why that's important here in just a second. But before we do that, we've got a bit of a showdown going on. And so we've got that more expensive wear parts blade head to head with that Kinsey blade. And Clayton is running that on his planter right here, and this is 1 year's wear. And so we figure this has 70 row acres on it. We're not seeing much wear yet with that wear parts blade not losing any diameter, and that Kinsey blade just losing a 16th of an inch. We're going to continue to look at that as the years go on right here. All right, so I mentioned that wobble and why it's important. So for example, on this unit over here that we rebuilt, we put new blades on. And whenever we shimmed those blades up, we found that on one side, we had too much contact. On the other side, we didn't have any contact at all. Whenever I put the business cards in, they slid all the way together. We did not have any contact with those openers at all. That's why that wobble is important. And we have to check that contact in 4 spots around the circumference of that blade. So it's very, very important. If we have too much contact, we're going to increase that bearing side load, and we're going to flex that blade more than it was designed. We're also going to start to wear the inside of that blade with the seed tube guard. But conversely, if we don't have enough contact, we can run to this scenario here in the top right with that W trench. You guys can see that ribbon of soil in the bottom of that trench right there. That is what we do not want. While that's not totally unavoidable, Clayton and I have both run into circumstances where you have inspect blades shimmed properly and we still have that W trench, but we want to avoid that if at all possible. All right, so we look at what that shimming ratio or that shimming distance needs to be here. Now Clayton and I have went down the rabbit hole trying to figure out what does that shimming distance need to be. Here's what we've come up with. So we've got planter brands and models right here. And it's interesting to see the evolution here. We look at this Kinsey 2000 with those 3mm lighter duty blades that had more flex. They also called for more contact. But as we introduced those 3.5, those heavy duty blades that we see today, we backed that contact off. You can see the different models right here and the different contact. But what we came up with is if you're running OEM blades, utilize these measurements right here. Now, if you're using aftermarket blades, which there are some very, very great aftermarket options, you're going to consult that manufacturer on what they recommend that contact to be, because they know what the bearing side load that they can withstand, and they also know the flex of their blade. So it's very, very important to check with that aftermarket manufacturer to see what they recommend for that shimming distance. All right, C-tube guards. So these guys need to do two things for us, really. One, they need to keep those openers from pinching in too far. And two, just as the name implies, they need to protect that seed tube. And so if we're running that OEM option right here, that standard wear option, we are absolutely going to want to replace that each and every time we replace those C-disc openers. Now, if we're running something like a heavy duty or a high wear Exapta arm or a C-tube guard, or we're running a high-speed system, many times those come with a high wear C-tube guard, and we're gonna wanna check the spec for that specific manufacturer. Typically, that's 5/8 of an inch, but it varies from manufacturer to manufacturer. And so this is what we do not wanna run into. We can see that little ribbon of plastic right there. So that opener came in, wore the side of that tube, and as that seed drops down that tube, that seed could catch that little piece of plastic right there, maybe bounce out of the seed trench, maybe cause improper spacing, things like that. And that is what we absolutely do not want.
Looking at this video coming up here, this is from one of my neighbors who happens to be a really good farmer. But this video shows if we don't keep our row units maintained between the openers and don't take a look at our guards, this is extreme, but it's also real life. This happened on his planter, and this is why I do recommend taking your openers off every year and inspecting every component of that row unit.
Might be time for a new seed tube. Wonder where that scraper went. Huh. Oh.
All right, so now that we've talked about C-disc and seed tube guards, let's dive into some gauge wheels right here. Now these guys gotta do many, many things for us. One, they gotta keep and maintain that depth. Two, they gotta help us maintain that furrow integrity. So what we're gonna look at here is first, before we take the time and adjust these properly, we wanna make sure they're in good working order. By doing that, we're gonna spin that gauge wheel. We're gonna make sure that inner lip isn't wore off. We don't have any humps or abnormalities in that gauge wheel. Then we're gonna go into shimming that properly. How Clayton and I like to do this is lift that gauge wheel up to planting depth, and we're going to slowly drop it. And we want it to drop on its own. We don't necessarily want it to drop and bounce back up. And so that's gonna help us maintain that proper contact with that disc opener. All right, so now that we have them shimmed up correctly, we want to verify that, and this is the fear that we have with shimming those improperly. So you can see that right gauge wheel right there is picking up some of that dry soil and dropping it directly on top of that seed in that trench. And so this tells us that we do not have enough contact with that opener and a tight enough seal that soil is getting in there and then therefore getting picked up and dropped in that furrow. This is closer to what we want. We can see neither of those gauge wheels are picking up any soil on the inside of them and dropping that into that furrow right there. That is what that proper gauge wheel shimming is going to achieve. Now, what if we can't get to that? What if we have too much slop or too much play in those gauge wheel arms? We have some great aftermarket solutions. And so the OEM option that we have right up here is that threaded insert in the very middle there, and then the two wear points on the outside. And so while that is an updated design, it still does cause issues with some low wear right there. We can get some wear in that arm and get some play. When we go to some of these aftermarket solutions, so right here we have that Copperhead or that RK gauge wheel arm repair kit, utilizing those shims to properly adjust that gauge wheel. And we go to the Copperhead single bearing arm. And so a lot of these arms have went to a sealed bearing inside of those arms to shore up that play. So we've got a wear plate here where that mustache rides, just as well with that Coyote manufacturing arm right here. We've got sealed bearings inside of there, and we have a wear plate where that mustache rides. All right, then we get into some different options. We've got an option from GBGI right here. Once again, utilizing those sealed, non-greasable bearings inside of that arm and as a hardened area for that mustache to ride. Then we go to the Precision Planning Durawear arm. These guys don't utilize a sealed bearing, but a bushing inside of a bushing design. And once again, that wear plate right there for that gauge wheel mustache to ride. All right, then we get into the Norseman arms. These guys do things similar, but a little different. And so they do have that sealed bearing right up top there, but then they move that shimming point from the pivot point down to the point of contact with that wheel. And they believe by moving that shimming point closer to the point of contact, that gives them the advantage. Now I'm gonna let Clayton talk about that Norseman arm for the Kinsey model.
So this is the Norseman arm for a 3000 through a 4000 series Kinsey. The reason I want to talk about it is on a 3000 series splitter, I've had a few models over the years where it's really hard to get the shimming of the gauge wheel correct with the opener. It's very hard to get it right up next to the opener. Even if you pull all but one shim out, can't get it. Didn't matter if you had new rubber on the gauge wheels. What I've learned is this kit that's on the screen for the Norsemans, for the 3000 and 4000 series planners, does fix that issue with the split rows. I'm able to shim it right, easy to shim it here on the bottom. Never have to remove this for any reason except for checking the wear inside that fitment on the end of the arm. How you install those is, you see in the upper right picture right there, you're going to drive the original shaft out of the row unit, and then we're going to install that threaded insert. That allows the gauge wheel arm to be threaded onto the row. And then again, like I said, we will shim at the bottom. That did take care of my issues. Currently today, that Norseman arm is the only aftermarket available option for a Kinsey 3000 and up to add that to a planner. I have heard there are a few other manufacturers that are working on aftermarket options today for a Kinsey planner.
All right, and then we go with that copperhead solution right there. For the case, 955 through 2000. Now that is a greasable option right there. All right, now that we've got our gauge wheels shored up, we're gonna look at the Kinsey arm here, kind of make a mention of it. And so look at some of the upgrades that they made with that 5000 series row unit. And so they're utilizing that castle nut right there to make that in and out adjustment. And they have a fiber bushing on the inside for that wear point right there. This is a very, very heavy duty option that Kinsey has integrated into their 5000 series row units. All right, now that we've got that squared away, we're gonna index our planner. How are we gonna do that? Just like this.
All right, it's almost go time to plant for this season. Before I drag the planner out of our shop here, I've got one more critical step that I'm gonna take before we start planting. That step is what I call indexing the row units. So to do that, I'm going to take two pieces of square tubing, 2 inch by 2 inch at about a foot and a half length. You can also use 3 by 3 square tubing as well if you would like. My next step is we're going to deepen up the T-handle as far as I can. So right there, planter is on the ground, by the way, in planting condition. And then what I'm going to do is we're going to take that square tubing, we're going to lift up the gauge wheels one at a time here, and we're going to slide that square tubing in following the opener. I want to have that square tubing leaned up against the opener from front to back all the way across, and then set the gauge wheel down on top. We'll do the other side right here and set that gauge wheel down. Next step is we're going to take that T-handle and we're going to shallow it all the way up till I can go no further. So right there is where we land. That is notch 4 and 3. Then we will go to each individual row after that, and we'll do the same exact steps. The last step I will make is labeling every single row with a filter marker. That's my 0 point. So you know if we start changing depth, we go down here and say somebody messes up a row, I know my home place to get back to. Not all your T-handles will be the same after you do this process.
All right, so many times Clayton and I get questions of, oh, hey, I don't have a concrete pad big enough to unfold my planter and drop it down and index it on. So no problem, grab you a 4x8 sheet of plywood. You can either do this folded up or you can do it unfolded, but drop that planter down on that piece of plywood right there and we can index the row unit just as we did there on the concrete. All right, here we have two different examples. We have a 2020 John Deere 1775 24 row, and we have Clayton's 2012 Kinsey 3660 32 row splitter. On the left, we have the depth handle position from top, and then for each of those planters, we have the number of rows in those respective positions. Now you'll see we have many different rows and many different positions here, and that's okay. Like Clayton said in the video, it doesn't necessarily have to be in the same depth handle position to plant at the same planted depth. And so that is what indexing does for us, is it zeroes out those row units across the planter bar to be planting at the same planting depth. Now Clayton's going to talk more about planting depth here later on and the importance of that. All right, here we have just those options or those instructions printed out here. Now Clayton and I asked that if you get one thing from this presentation, it be planter indexing. This is something so simple and so easy to do and can save you money with that planting pass to help optimize that pass. Now this, one thing to keep in mind here, this isn't necessarily setting planting depth the first day of planting. You're still going to have to dig, but this makes for a very, very good starting point whenever you're in the field making those in-field adjustments. All right, so what if we did that indexing process right there and we found some issues? We found some rows that were big outliers. Maybe it's in a pinch row or requires more downforce to get to depth, sees more wear, things like that. We want to look at some of these depth mechanisms right here. Maybe we need to take a look at this gauge wheel arm right here. Maybe we have a big divot wore in here. Or maybe the mustache right here is wore and we need to replace that. Or for those Kinsey planters, maybe in that dog right there, we have wore a very, very big hole in there and maybe we've almost wore through as we have in this case right here. All right, now we're gonna move on to seed firmers. These guys need to do two things for us. They need to keep the seed in that trench. They also need to put just a little bit of pressure on it to make sure that we get good seed to soil contact. A couple things we need to look at. We need to drop the planter down, and we need to verify that we have 16 to 20 ounces of pull on that seed firmer right there in planting conditions. Also, we need to look and make sure we don't have a V or a U shape wore in the bottom of that seed firmer right there. All right, last but certainly not least, we have the closing system. This guy has two major jobs for us. This is going to be the last time us as farmers touch this seed before it starts growing. One, we need to blow out any compaction that we made with that True V opening system. Two, we need to properly reset the soil density around that seed to promote very, very good emergence. All right, so there's a couple things that we need to do to that closing system while we're in the shop with it. First, we need to make sure that they are shimmed properly. Now you're gonna want to contact your manufacturer of your closing wheel to figure out what that shimming distance need to be. Secondly, we're going to want to align that closing tail properly over that seed trench. Now there's three different ways that we can do that. One, while we have the planter in the shop, we can drop it down on the concrete, pull ahead a little bit, and it's going to make some marks in the concrete and tell us where that furrow would be. Now that's not my favorite option. Makes some very wretched noises and some marks on the concrete, but nonetheless it is an option. Secondly, we can make ourselves something like this. So this comes back here, hugs the back of this row unit, and has this rod out the back to help us align that closing system. Or 3, we can find us a nice day in March or April, go out to the back 40, we can drop the planter down, pull ahead 10 feet, and we can align the closing system that way. And one thing I'll keep in mind while I'm here is this spring hole right here. We're going to talk more about this here in a minute, but many times that spring is made out of a hardened steel, and that spring hole made out of a cast steel, and that can prematurely wear out that spring hole. We're going to talk about an option for that in just 1 second. Let's get to our aftermarket options right here. First, we have 2 kind of DIY options. The first one of those being that Copperhead Ag Repair Kit. And so we're going to weld this ring onto that closing arm and then install a sealed bearing inside of that ring. Second, we have that PPS repair kit right here. And so this is the ream it yourself, do it yourself kit right here. We're going to ream that arm out and install this teardrop shaped bushing inside of there. Those are going to be our cheaper options. And then we can go to our fully replace options. These are going to be much less labor intensive, much quicker repair that we can make right here. We've got our Solid Rock Ag Kit right here, utilizing a sealed bearing. We've also got the Exact-Align Pro model right here, once again, utilizing a sealed bearing. And we have the PPS Complete kits for the John Deere and the Kinseys right here. I'll get to that spring hole wear kit. And so we can either buy this part together or separately. We can buy that $2.50 spring hole wear kit. And so we're going to ream out that spring hole and we're going to install that hardened bushing inside of there to prevent that future wear in that spring hole right there. And we have the PPS Complete kit for the case 1200 right there. All right, then we get into meters. Okay, we're going to get into meters right here. There's many different brands of meters on the market. Now, I'll be the first to admit, I'm not an expert on fine-tuning all of these meters. There's many, many different options, and I don't know the exact ins and outs to optimize all of these meters, but there's some commonalities between all of them. First being, we're going to want to consult our manual. Specifically for the John Deere Exactimers, there are 19 pages in the manual talking about meter adjustments. And so the first place may need to be is looking at our manual. We'll look at some commonalities between all of them. We're going to look at shims, specifically in those John Deere and those VSET models right there. It's very important to get the shimming correct in those meters. Once again, we're going to talk about lubricant. So looking at that graphite, making sure that those seeds are lubricated properly in those meters. Clayton's going to go into more detail with bulk fill on that here in a minute. Make sure that we have the correct seed plate sizes and clean up and store those meters properly. All right, a couple more things on meters. Let's talk about finger meters for 1 second. Finger meters can do a great job, but they are very, very maintenance needy. And so we're going to make sure we get those meters run each and every winter. Having run some finger meters on a stand myself, I can speak to how finicky they are. You get this finger set just a little bit too tight, can greatly impact the meter performance. So like I said, they can do a great job for us, but they just have to be fine-tuned. And so running those meters, having those meters run on a stand each and every winter ensures that. When we get into vacuums, so we've got this seal right here, so we want to make sure that those vacuum seals are in proper condition. You can see here, we have a seal with us that was causing us 3% singulation loss. You guys can see how small the crack is in that seal right there. But that alone was costing us 3% singulation loss. Now that is not a very expensive part to replace, but it could have some serious implications for us here. All right, then we get into some high-speed systems. So we have the cleated belts. So that's the Kinseys, that's the Ag Leader, and that's the Precision Planting Solution right there. So those cleated belts, we're going to make sure that we're not missing any cleats in those belts. Specifically in that precision system, make sure that those transfer wheels are in good working order. So they don't have any mud or dirt behind them. Make sure they're cleaned out. We're going to want to take that belt out of that precision tube each and every winter. Moving on to the Kinsey or the Ag Leader, make sure that those transfer wheels up top are in good condition. Make sure there's no cleats missing off that belt either. Then we get into the exact emerge solution right here. Now we're gonna wanna take that belt out for wintertime and store that in a climate controlled building. But then once again, make sure that brush is in good condition overall right there. All right, so maybe we haven't made that upgrade to high speed or electric drives. We're gonna wanna still maintain our drive system. Starting with where it starts out, right here at the transmission. We're gonna wanna make sure that there is the proper inflated pressure in each of these drive and driven tires. Make sure the bearings in our transmission are in good working order. We think about these bearings, they don't spin super fast, but they make many revolutions over the life of that planter, and it's easy to not notice when they go out. And so here on this unit over here, this planter can't be any more than about 10 years old, and we spin this. If you guys can hear, it looks seemingly pretty okay, but whenever you spin it on its own, it's in very disrepair right here. And so it's easy to miss those bearings being out. That's gonna cause chatter in that drive system and therefore affect our meter performance. Once again, while we're at the transmission, we're gonna wanna look at those idlers, those tensioners. Make sure those are in good working order, the bearings are in those, and everything is in good working order. Once again, oil all of these chains very regularly. As we move across the bar, we're gonna make sure our drive systems, our drive components are in line with each other. As you can see, these two shafts right here are very out of alignment. Once again, check those tensioners. Each row has one of these tensioners. Make sure we don't have those speed bumps in those tensioners. And if this is the chain that's on your planter at home, it's time to replace it. It's actually past time.
As you replace that chain, it's also a good time to go ahead and pull the shaft out of the planter, and then you check those bearings. That's the best time to do it. I would probably take a look at those bearings probably every other year. Every time I've done an electric drive conversion to any planter that has age on it, I have found bearings out somewhere across that toolbar, which is odd. Those bearings don't run on dirt. They're not high speed. You think they last a long time, but they are short. They have short lives, just to say it plain and simple.
All right, so vacuum and bulk delivery systems. I'm going to talk about these very briefly. Clayton's going to take a deep dive into this topic here in a minute. But while we got that planter in the shop, make sure our manifold and our seals do not have any cracks or any leaks in them. So the manifold's on the bottom, and then those lids up top. Make sure there's no cracks or anything in there. While we have that planter in the shop, we can ensure that that agitator in that John Deere CCS system is working. So that's going to work whenever that planter is dropped down, the key is on, and that planter is plugged in. That agitator is going to work in a back and forth motion right there. All right, then we just get into some general maintenance things. So once again, those bearings, those bushings, we didn't talk much about gauge wheel bearings and things like that, but there's many other things that we need to make sure that are in spec. Air compressors, either for those airbags or row cleaners, make sure those things operate while we're in the shop. We don't have that issue the first day of planting. You can see here on the picture on the right, this guy's got a lot of things going on, but most obviously, we've got a catastrophic failure right here. And so I would venture to say that that crack was probably there before the first day he pulled it out of the shed. And so especially on those high-speed systems, they can really take some abuse to that planter bar, planting at high speeds. Make sure we're looking those over. Make sure there's no cracked welds, no cracks, or anything like there. All right, so here we have a video of this, what we would classify as wore-out John Deere ME5 unit. So we can see the play in those parallel arms right here. Remember, we're lifting that up. That's going to cause that row unit chatter side to side and up and down. Then we move on to the gauge wheels. We can see that those threads have gotten worn in those gauge wheel arms and causing some play in those gauge wheels. Look at those gauge wheel tail, or those closing wheel tails. We can see the play in those closing wheel tails. Once again, that spring hole that we mentioned, that spring is wore an elongated hole in that cast steel right there. All right, Clayton, I'm gonna let you take it through some of the specifics on some Case IH maintenance.
Don't forget as well, all your bearings, your closing wheels, gauge wheels, row cleaners, your drive wheels, all those bearings matter as well. We don't dive real deep into the bearings on the planner, but just think about those things as you do maintain your row unit. We will get into Case IH here, and the reason why we talk about Case IH separately is because their row unit, as far as maintenance goes, is a little bit different. Everything that Tony covered does still apply, but here's the differences. We look at a 2000 series row unit. We'll do some comparisons here between a 2000 and a 1200, but they're different. Like I said earlier, we've got following gauge wheels, leading and following disc openers, and then we've got a few other components I'll talk about here in the middle, followed by a two-stage closing wheel system. So for the openers, we talked about when openers should be replaced earlier in that chart. It does have the ranges for a Case IH planner. But for a 2000 series, we're going to replace those at 14.5 inches. They come factory standard at 15. For a 1200 series planner, they come factory standard at 14. We're going to replace them at 13.5. Being leading and following, when we go to shim those openers, they do not require the same amount of contact a conventional True V opener requires. The contact here is actually in millimeters. Basically, if they're making contact, it's going to be okay. But once that contact is gone and they're not making it anymore, we will remove one shim from the following opener, so the trailing opener, not from the leading opener. We'll start with that. Moving on back to throughout the row unit here, we start to look at a very critical part of that row unit. Here's the firming point. That firming point is following the disc openers. Since we have a leading and a following opener, they're not forming a true smooth bottom of that seed trench. They're actually going to leave a W. What this firming point or forming point, what they call it, is going to take the W out and make a more of a flat floor in that seed trench, where a John Deere or a Kinsey's not going to be able to do that, but it is very necessary here. Beyond that, you see this red component. That is what Case IH calls a shoe. The shoe is there in relationship with the reduced inner diameter gauge wheels. I call them RID gauge wheels. Reduced inner diameter gauge wheels take the compaction from your seed trench, and we're going to move it outbound of those gauge wheels. So we're more concentrated a couple inches away from that seed trench compared to being right next to it or within that trench. But since I have a lack of compaction here, we need to have some time for that seed to get down to the floor of that trench before that trench crumbles on top of it with dry soil being on top of that seed. So that shoe is there to prevent that. I do not want to run an RID gauge wheel on a Kinsey or a John Deere or a Precision planting row unit, or a White for that matter, because they don't have a shoe. We've got to have it there. We don't want to crumble that dry soil directly on top of that seed. Will cause some emergence issues if that happens. Next up is going to be the closing wheels. If I back up 2 slides here, the first stage closing wheel needs to be replaced when they hit 8 inches for a Case IH 2000 series row unit or 7 inches for a 1200 series row unit. So that's also a maintenance item. Back to the shoe and the forming point, those are also maintenance items. As that shoe wears and it becomes paper thin, you're going to replace it. At the same time, you're going to replace your forming point. The forming point, if it does get this bad, like the picture on the left here, you've got to replace it. We want to take that trench down and make a good floor for that seed. This is no longer going to do that. That concludes the maintenance on a Case IH row unit. The one thing, though, that Case IH does offer, which I think is excellent, is they offer productivity guides for a lot of their equipment that Case IH sells. So on the left, you've got the 1200 series early riser planner productivity guide. You can get that guide by scanning that QR code. This is basically the guide the technicians are using to inspect your planter if you were to have Case IH do it. So it spells everything out. We've got 82 items we're going to look at. For a Case IH 2000, that guide's on the right side here. We've got 60 items we're going to take a look at. That QR code there at the bottom right will get you that productivity guide. If you've got a Case IH planter, I do recommend getting that guide, printing it off, and utilizing it throughout your maintenance of that planter. Tony covered all the maintenance items that you should be aware of when maintaining your planter over the winter or even over the summer months. If you can maintain your planter in the summer and have it ready to roll, that is awesome. Being that we've got our planter maintained to the best of our abilities, we can now walk forward into the season. Day one, I'm going to call that Gold Day. So our Southern Illinois team and myself came up with this acronym being GOLD. So what do you think GOLD means? If you've ever passed a semi-truck on the interstate, you might have seen this sticker on their mirror, their driver's side. It says GOAL. And what that says is get out and look. That's really critical for a driver when they've got questions going on behind them, is to actually stop, get out and look. For us as farmers, it's gold. Get out, look, and dig. So I spend a lot of time, especially on the first couple of days, I'm patient. I don't care if I get 20 acres planted that first day. I'm going to make sure that I try not to have sins from the first day on. So we're going to do a good job because those sins will follow me throughout the whole planting season or throughout the whole year for that matter. Before I get into that, I do want to cover what PFR proven is. PFR proven is part of our PFR department as far as our testing goes. So what that means is for a product or a practice to get the PFR proven stamp of approval, it must have been tested at multiple locations, usually 3 or more. It must have been tested for multiple years, usually 3 or more. Of those 3 years individually, that product or practice must add yield. It also must be adding return on investment, positive, average for those 3 years. So it must add yield and it must be profitable. If it doesn't add efficiency and it doesn't make me money, I'm less likely to try that product on my farm. Day one, we're going to pull our tractors out of the shed now, and we're going to get ready to roll into that first day. But before going to the field, here's my technology checklist that I kind of follow year to year to make sure we're ready to go on day one. So taking this maybe 3 or 4 days ahead of time, know how to update your software quickly. I'm probably not going to tell you to update your software. Some of us are going to do it automatically. That is what it is. But if you are religious on updating your software, just know that sometimes there are bugs that happen with those software upgrades. Now, if you don't or are not religious about updating your software, know that if you have issues and you call tech support, one of the first questions they will ask you is what software you're on, and then you're going to have to figure out how to do it and do it quickly. They're not going to stay on hold with you or on the phone with you as you go through that process. So know how to do it quickly, and be prepared to do so. Next up is technology. I want to connect all your technology so that in my mind, what that means is making sure my globe is communicating to my planter monitor. Maybe you're running an Ag Leader globe and a John Deere monitor or vice versa. I'm going to make sure those messages, the NEMA messages, GGA, VTG, Hertz, there's a few others, I know where they're located at in the monitor and what they need to be for each of those. Once you have it set, let's take a picture of that and save it on our phones. We're going to make a copy and we're going to clear out last year's season's coverage maps. Coverage maps from the previous season should not show up. They might prevent you from being able to actually plant if they do show up in your monitor. Here's a pet peeve of mine. Keep field names consistent. So if I have a field named Tony 80 and Tony plants it and it's got a capital T, and then I spray it or I harvest it, and I lowercase t. If you don't have a driven or a hard boundary for that field, that's going to show up as two separate fields. Every time you do a name wrong, it shows up as a different field. So I like to keep that consistent for a couple of reasons. For myself, maybe I'm sending bills to landowners or yield maps. It makes my time much more efficient in the office. But if you're having an advisor, maybe it's a farm server advisor, helping you with your maps, transferring data through the cloud to get to the same bucket on the other side, getting your field names right helps. A good way to help with that, if you've got multiple employees helping you, is to buy a laminator. They're cheap on Amazon. And then taking an Excel file, naming the fields what you want, and then put that laminated copy in the tractor, the planter tractor, combine sprayer, anything that's going to map your pass. I want to keep those consistent. Upload new prescriptions and test those. So maybe you're new to that, okay? I want to be able to test that somewhere. Maybe it's a field right in front of my shop or where I maintain my planter. We're just going to make some test blocks out here and make sure it's going to work. They can be finicky from time to time to get them to work. Lastly, run all health system checks and calibrations. I want to get seed through it. So test it either in the ground or in the driveway, making sure we're sensing seed, we're hitting population, everything's working as it should. I don't want to get out to the field on day one and have a problem that's going to cost me 2 days of planting. So let's do that early on in the season. Once we get this wrapped up, my technology checklist, we're going to go ahead, we're going to move on, we're going to pull a planter out in the field. The first step that I'm going to take is I'm going to ensure that planter's level. If you have the same combination you had last year, tractor and planter, and you've done this, you're probably good to go. But if you maybe changed tires or got a different planter or a different tractor, we want to make sure we're going to level from front to back, okay? Typically that toolbar height, and this is going to vary by planter brand, but typically 20 to 22 inches. I want those parallel arms as level as possible. We're going to do this while you're moving too. We're not going to do it stationary because that planter could rock back a little bit as you stop, so we want to be moving slowly. If you can't get it perfect, let's say you got a drawbar planter, you can't get it perfect. What we're going to do is we want it to be a little bit tail back as opposed to nose down. So if you can't get it perfect, you got to pick one of the two. It's tail back. Very little though. The reason why we want tail back, if I've got it nose down, my row cleaners, if they're fixed, we're going to dig, we're going to be way too aggressive. If I've got a Coulter on, same thing. If you pitch a Coulter nose down and it gets below your seeding depth, you start to bring up moist soil into your seed trench and we can smear it. We can also bring up that moist soil and it goes right to your gauge wheels. You start to pack up your gauge wheels. We do not want to do that. Also, it takes the pressure off your closing wheel tail. We want that at optimum. We're going to talk about that here in a little bit. If we don't have that at optimum, we're not going to bring in that seed trench, shatter the compaction, and firm the soil around the seed. Don't forget to level side by side. This is going to go for you guys that maybe just bought a new planter or a new to you planter. Your center transom wheels might be in a different position than your wing wheels. That's okay, as long as your toolbar is running level. That's the goal with this. Don't forget this step. Downforce adjustment and the data. So we're going to lace in some data as we talk about these adjustments you're going to make with your planter pass. Downforce, I can talk on this for a long, long time. In my opinion, you probably should be making downforce adjustments in every field, or at least looking at it, getting out and digging. We're going to start with how I do it. So when I was young, just learning how to plant, maybe I was 13 or 14 years old, my dad would say, hey, get out of the tractor cab, leave your planter down, you plant a little bit, leave it down, walk back there, we're going to grab a gauge wheel and we're going to try to spin it. If it spins easily, you need to increase your downforce. If it doesn't spin, you've probably got too much downforce. Or if it barely spins with your two hands, you're probably about right. That was fine for me back then when I was learning how to plant. But today, looking at that method, you get 1 point in the field. and you're making a decision for the whole field based off turning gauge wheels, your contact patch below your gauge wheels is not much. So I'm making a decision, maybe I stopped in the wrong part of the field. Here's how I'm going to do it today. A little bit different look here. I'm going to raise up my closing wheels, and one way to do this, you can use ratchet straps, or Precision Planting sells hooks similar to this. Now Beck's made a batch of these for me to hand out for planter clinics, but Precision Planting sells these on their website for about $15 a hook, or Iowa State University has a drawing for this. You can download that and have your local machine shop cut these for you. Here's how it works. We're going to actually hook up the closing wheels with this hook. We'll bring it up here like this. We're going to hook that row up. And then I'm going to plant. What it's going to allow me to do, go however far you want. If you want to go all the way across the field with one row hung up, that's fine with me. You're going to learn a lot from this, and it's an adjustment that's going to make you money if you get it right. Here's what we're looking for. On the left, if I'm too light, I come back here to my exposed seed trench, and I've got dirt that has filled in that trench. Two things are happening. I'm getting dry dirt on top of my seed, but also I probably am not planting at my planned or targeted planting depth. So I want to make sure we're not too light. We're going to be bouncing at that amount of downforce. On the upper right here, there's a big shadow in this picture, but a lot of that's caused by it's smeared. There's no cracks in the sidewall. It's smooth. We've created too much downforce. If I create too much downforce, basically I build bricks on both sides of that seed. My closing wheels can't take out that compaction because it's too much. And then my roots, they're going to either grow path of least resistance or not grow very much at all. So we want to make sure that we do not do this. Another way you can see this, you don't see it here in this picture, but if your gauge wheels are actually fracturing and peeling the soil from the behind, you've got too much downforce. Here's what I want to see right here. Being able to see that fractured in that seed trench, the line's right there. Then I can take a knife or a seed finder and we can start to crumble that up. If it crumbles and releases fairly easy, you're about where you need to be, okay? The other thing is, in your monitor, if your monitor gives you the metric of ground contact, I want that number fluctuating between 98 and 100%. If it's always at 100%, means that I'm probably compacting, overdoing it somewhere. Okay, you've also got a map with this. If I'm at 98% or lower a lot of the time, maybe I'm not hitting 100 at all, I don't have enough. And we're going to start doing this, and it's going to affect our planting depth. You're going to learn here pretty quick. Planting depth is the most critical adjustment that I can make with my corn planter. Here's those hatchet roots that we can cause by having too much downforce. The agronomist in the picture is 6 foot 6 inches, okay? That corn is below his shoulders, tasseled, having a bad day. What did this decision or adjustment cost me? Potentially quite a bit. So we want to make sure we take our time adjusting our downforce properly. When we get into hydraulic downforce systems and settings, things can get a little bit more complicated here. On the top of this chart, we've got the brands who currently have hydraulic downforce systems. And then we've got what those systems are called. Next up, we've got what the load on the gauge wheel. So what metric are we looking at here? John Deere is margin. That is basically gauge wheel load. Precision Planting is also margin, but it's calculated as the average of the minimums. So how I understand that is the minimum amount of weight it took for those openers to penetrate the soil and our gauge wheels getting to the point where they make contact with the mustache and then the load cell. So whatever it took to get there, from what I know or how I understand it, is the average of the minimums. Next up, Ag Leader with SureForce is going to be gauge wheel load. I can understand that. So what those gauge wheels are carrying as we go across the field. Kinsey, basically the same thing with their system with True Depth, is sense force, but I understand it as gauge wheel load. Now the applied force for the majority of these, what you'd see in the applied force map, is how much downforce pounds those hydraulic cylinders putting down to achieve our setting. So our setting is next. John Deere is going to be target margin. It's a number value, 0 to whatever that upper value is. So my starting point for me on my operation is going to be 100 pounds. Usually I am not below 100 pounds of gauge wheel load. In this case, 100 pounds of target margin for John Deere. And that could be any number you can pick. For delta force, that's delta force target. Basically, that's also gauge wheel load. They've got 3 settings. Light, which is 50 pounds, standard's 100, heavy's 150. I'm going to start a standard and then figure out if I need to go one way or the other. But maybe 150 is too much. I can customize each of those values. So I can make the 100, I can make it 90 or 110, okay? The 150, I can make it 140 or 160 or higher. So I can kind of make that, customize it for what I feel is the proper pressure. So for Ag-Leader SureForce, that's going to be light, medium, heavy, and maximum. We'll talk about those presets here in a minute. Kinsey, the true depth setting for it, for the input, is 3 presets, all based on gauge wheel load. So I can understand gauge wheel load. As far as your map metrics, here's what we have offered from each of those systems. And then the applied force range. John Deere currently does not have lift, so their range is 50 to 450 pounds positive. Precision planting is negative 450, so that's lift, to 650. Ag-Leader, negative 250 to 650. And then lastly, Kinsey, negative 150 to 650. So let's talk a little bit about how these hydraulic systems work. The field that I happen to farm on my farm, historically, it was no-till. But we pattern tiled it recently, and that year we chiseled it to work down those tile lines, and then we planted it. If you look at the field here, it's a 67-acre field. In the upper right is the gauge wheel load target. So medium with SureForce is 100 pounds of gauge wheel load. When I set that target, it's trying to keep that for the whole field. Now the map that you see here is applied force. So whatever amount of hydraulic pressure it took to achieve that 100 pounds of gauge wheel load. If I look at this from a setting standpoint or applied force standpoint, the dark green across this map is negative 200 to negative 75 pounds, 17 acres. That's all lift. Next is light green, negative 75 pounds to 0, 26 acres. Again, lift to 0, 26 acres. Yellow is going to be 0 to positive 75, 17 acres. And then light red, 75 pounds to 150 positive, only 3.7 acres. So if I'm coming in here at the spring, what percentage of the field would have it been right? Probably right here. That'd come up to be about 1/3 of the field it would have been right. 2/3 of it would have been wrong. Lift was critical in this field, and I do believe it helped. But lift can also hurt you. Here's the consequence of lift. So I'm going to pick on my dad here a little bit. He calls me 2 days before this field. He says, hey, I'm planting an alfalfa sod, very finely worked up ground. He goes, those closing wheels that you made me purchase are lifting up seed and shallowing it up. And I thought there's no way. We've done a lot of testing. I've been behind planters for a long time. I didn't think it was moving seed. However, we get to this field, and it was a replant scenario in 2023. That was a drought year for us. Very dry conditions, mellow because we worked out the old stand of corn, and I planted in my headlands. And I got here to the north side of the field, and I lifted up my closing wheel like I always do and planted across the field. I started looking at my seed trench. My depth, even though I was targeting 100 pounds of gauge wheel load, my depth was at 1 inch. And I was set on 2 inches of depth. So I learned pretty quickly here, pretty early on when I had that system, we better be getting out and looking. Because if I would have planted that corn at 1 inch, who would have been in trouble. So what I ended up doing there was I increased my downforce from medium to heavy. Counterintuitive. My mind wasn't telling me to do that in the cab, but getting out and digging proved that that was an important adjustment to make. So I increased my downforce, got back down to 2 inches without changing the planting depth. Here's another example off my farm. See, about every 16 rows something's going on. Automated downforce, in my opinion, is important. It's making the adjustments here. Maybe this was a dedicated path for my grain cart to run to the end of the field to fill the trucks, the harvest before. I'm not sure exactly what was going on in this field, but the downforce is picking it up. Here's my gauge wheel load map, okay? We're set on medium here, so we're gonna try to get close to 100 as an average across the field. You can see that didn't change. If we back up, here's what it took to get there, okay? Average for the whole field was 77 pounds positive. One more example here from one single field. In the fall of 23, I applied a strip till fertilizer trial with a Yetter Maverick strip till shank. In this part of the field was where that trial was at, and then my dad came and applied the ammonia on the rest of the field with a Case IH 5310 bar with a conventional mole knife. You see where that red box showed up? The applied downforce changed where that Yetter machine ran. It was actually much lighter than where that Case 5310 bar ran. So it picked up for it and it adjusted. But look at this. My downforce, average applied in that field, was 232 pounds. The most downforce I've seen for the 24 growing season. And this was my highest yielding field. Downforce is really critical to get it right. If we go back to 2023, the gray bars on this chart across a lot of my fields is the target downforce. So this in that year was mostly medium throughout that farm. Not all my fields are shown here. But then I wanted to show what the applied was to keep it at that target. The green bars is the applied. As I go from field to field, it's sorted from the field conditions. 234 with this field to keep it at 90, 150, all the way down to 56 pounds. You can see how hydraulic automated downforce makes changes from a field by field basis. But I still get out of the tractor and I make adjustments. When we look at research data, we actually do a trial on this. Here's how we're going to set this up. I'm going to take a planter. So this is Ag Leader SureForce, and we're going to plant my SureForce treatments. Then I'm going to pull my hydraulic cylinders off and put the standard springs back on that planter. What you see in this image is one of those trials across a 40-acre field. We've replicated it 6 times, and we've got multiple soil types here. It's also randomized across that field. When I look at 3 years worth of that trial, the control being the medium Kinsey springs, 3 years of data here, we're going to control or compare each of these back to that control. So heavy spring for 3 years, 1.7 bushel advantage. Medium SureForce, 1.8. Heavy SureForce, 3.1 bushel advantage. So it's not huge, but if you're going to go back and look at those trials from a year-by-year basis, there's some years where that was a lot more than 3.1, but there were also years where it might have been floating at 0 or less. It shows that there is a setting that usually is the best case scenario for your corn or soybean crop. So not saying that springs are any better or worse or hydraulics any better or worse. Sometimes the setting up here is what really matters. Getting out and digging. Next up, another trial is our planter omissions trial. So this is new for the 2024 growing season. 1 year of data so far. My controls on the bottom here. Standard automated hydraulic downforce with the Deltaforce system. Floating row cleaners. Second notch closing wheel pressure on my closing wheel tails with Yetter poly twisters. 99% singulation or above. And planted 2 inches deep. We're going to talk about this study several times coming up But here's the first adjustment. It is downforce. So if I go heavy or lighter, so one setting change over my standard automated here, we'll lose roughly $6 an acre. Not a whole lot, okay? Now we come into the soybean study. Again, same treatment here with the Ag Leader SureForce system. Control being medium springs, heavy spring, we gain 2.4, medium SureForce, 0 flat, heavy SureForce, minus 0.2. Again, the setting matters a lot. I believe that automated either air system or I prefer hydraulic row by row downforce is going to pay. You've seen my field examples. I'm a believer in it. I would buy it again, okay? Based on the data here, it's kind of hard to make decisions based off a couple bushels, but I've seen my field examples. I've lived through it and farmed through it. I believe it's added to my yield. Bringing the downforce all together with my field examples, the planter omissions trial, I is still just a believer in getting out and digging and looking. You're going to learn here pretty quick that depth is a critical adjustment, but downforce and depth are related. So to hit your depth all the time, your downforce has got to be correct. Next thing I'm going to do in the field, we're going to double check. My monitors or my meters are singulating like they're supposed to, but I'm also going to look at my population. With your planter closing wheel hooked up, it's a good time to check this. This happens to be from a local guy at home. He planted about 400 to 500 acres and must have not got out and looked with a tape measure and checked where his seeds dropped. I don't know if he's got a monitor. I happened to drive by his field and walk across it, and those seeds are placed 12 inches apart. So we've got to double check things, make sure they're working properly. Maybe I didn't put the right sprockets on for my ground-driven planter to plant the population I'm trying to achieve. So I just want to double check things before we get hot and heavy. I'm a believer that singulation pays in corn, but it also pays in soybeans, okay? So how can we singulate in soybeans, and what are the yield advantages by doing that? So if we look at some PFR proven data here, the control being precision planting 80 cell soybean plate in 15-inch rows, 76 bushel beans. Singulated precision planting 56 cell plate, 77 bushel gain, or 77 bushel beans. We gained 1 bushel here by utilizing that green plate in 15-inch rows with a conventional seed tube. Now I run Ag Leader HighSpeed planters on my farm. They came factory standard with a 92 cell plate. The moment I put my 46 cell plates in 15-inch rows, I never have a soybean beside each other. That plate coupled with the SureSpeed tube or the Kinsey TrueSpeed tube did singulate beans very, very well. It makes it easy for me to do stand counts for research trials, but also I believe when a soybean seed is not paired up next to its neighbor and have some space in between them, those seedlings have a lot more vigor. Lastly here, for a John Deere vacuum meter, you can replace the 108 cell plate in 15-inch rows with a 64 cell plate. There's your part number. That's going to help you singulate with a John Deere planter. Speaking of singulation in corn, for this planter omissions trial, we were trying to target 99% singulation or above for a control. And then for our singulation adjustment, we wanted to hit right around 95%. Here's how we did that. You watch this video here, you see a green piece of tape. That's a simulated skip. I ended up plugging that hole later on. And then I've got some multiples that just passed by. So we're going to showcase skips and multiples as we plant across this trial, targeting 95% singulation. You see that come around again. Here's my tape right there. We ended up plugging those. Again, my target being 95%. What's that going to cost me? If you go from 99% singulation down to 95, 1 year of data so far, $27 an acre. I want that money in my pocket, okay? From a singulation standpoint, a lot of meters out there today, I don't believe there's a bad one today. We need to focus. If we do not have a meter that can singulate, or we're not maintaining our finger meters, maybe I don't have a monitor that reads singulation. By golly, if I farm enough acres, we're going to buy one. Because this is money back in my pocket. We're going to pay for that monitor very, very quickly at $27 an acre. Row cleaners. I'm a big believer in row cleaners. I'm a big believer in adjusting them for field and for conditions. I want them spinning 90 to 100% of the time in no-till to strip till. Conventional till, 50 to 60% of the time, moving mostly clods and residue. In a no-till scenario, here's what I'm trying to get. We're going to move the residue out of the way of a Coulter if I've got one, and then my openers. But I also want to move the residue out of the way of my gauge wheels, creating a clear path for my gauge wheels to run. No speed bumps, okay? I don't want no depth irregularities caused by my row cleaners. Now through time, we get in a hurry, we get lazy, we stop adjusting row cleaners. Some of these row cleaners, if you don't have air adjust, they can be time consuming to adjust row by row. You're out in and out of the cab 30, 40 times, getting them perfect. And you need to be doing that in a field by field scenario. So here's what I do recommend. Something as simple as this. A precision planting air cylinder and a clean sweep control box. Takes no electronics. Super simple, it's priced very well and very easy to add on. A lot of row cleaners have the fitments, or you can buy the fitments, the brackets for those cylinders. You don't have to spend $1,000 a row to buy a really expensive row cleaner. I just want you to have the ability to adjust it easily in the field. Here's why. When I look at this, I do a lot of scouting every single year. And when I scout runts, late emergers, or non-emerging plants, a lot of the times you'll see residue right by that seed. In this case, he emerged barely, residue was there. He leafed out underground, residue was there. He didn't germinate, residue was there. He's coming, residue was there. This one here, he gave up, residue was there, okay? I want to make sure I keep that residue out of the trench. On my farm, we fall strip till a lot of our acres going into corn. My strip till bar, previous to 2024, we did not have row cleaners on that bar. I'd see this very common. That shank would come through, then the sealers would come through and it'd roll all that residue right into my seed trench. My row cleaners on my planter aren't going to pull it back out. So think about this on every pass you make too. Your residue load in the trench is very, very important to keep out of the trench. When I look at yield data here in corn, my control being no row cleaners, my floating, we gained 4.2 bushel per acre, okay? 25 pounds down, 4.4, not much more, but this floating, that was set at the right depth stop on those row cleaners, okay? 25 pounds down, I'm going to run down pressure when I'm planting at high speeds. If those row cleaners get to balancing, what they start to do is they create speed bumps for my gauge wheels. We start moving that row unit up and down. It's a constant battle then. Once you start this motion of both moving, it's hard to get that corrected. In soybeans, 1 bushel per acre. My yield win percentage, 60% of the time it adds yield by utilizing row cleaners on a bean planter. They do work, but I'm going to focus on my corn planter first if I have dedicated planters to both crops. If I make them too aggressive, $13.50 an acre lost. Okay, so we've seen the gain by having them on and adjusted properly. Now if I overdo it, we create a trench, we make an area for water to run. We also make an area for water to sit. Both of those are bad. If water sits, we drive the oxygen out of the soil, then we will create emergence and germination issues. Planting depth, like I said earlier, very critical adjustment to get this one right. Light downforce here. I'm not going to keep seed depth, targeted depth, if my downforce is set improperly. Again, just reiterating this, seed down at the bottom, fractured sidewalls at the depth I'm trying to achieve. That is my goal here. When we look at research data for planting depth in corn, 3-year multi-location data here, my control being 1.5 inches. If I shallow up just 1/2 inch, 13.1 bushel per acre. Do that at your commodity price for corn. It's enough money to make the right adjustment and get it right. But if I go up, so I go deeper here, 2 inches, 1.3 bushel gain over 3 years multi-location. That's my target. 2.5 minus 2, and then 3 inches deep minus 6.7 bushel per acre. Ultimately, the penalty for going too deep is less than the penalty for going too shallow, okay? So if I don't know where I want to be, I always kind of err on the deeper side of things. Look at that planting omission study again, making the adjustment of planting depth from my 2-inch control, shallowing up 1 inch. We lost $51 an acre, which is plenty of money for an adjustment. However, if we pull the Kentucky data out of that, it would be $70 an acre. Now, why would I pull the Kentucky data out of it? They had a favorable rain right after planting, and it was a good rain, and their inch planting depth actually yielded more than the 2-inch. However, in most cases, that's not going to be the case. So I'm going to target 2 inches, at least where I'm from, and a lot of our marketing area. The reason why this seed here was planted at 2 inches, nodal root development needs to happen deeper in the seed trench. If we're up high, we can create rootless corn syndrome. Later on in the season, if we do get a wind event, that corn has a higher chance of going down on us. We want to set those nodal roots as deep as possible. Looking at soybeans, similar data here. My control being 1 inch. If I go 1/2 inch, so we just shallow up 1/2 inch, 5.5 bushel. Take that times 10 bushel beans, $55, okay? We want to make sure we're planting beans deeper as well. 1.5 inch here, plus 2.4 bushel, 2 inches minus 2.4, and then 2.5 minus 3.2. Again, with beans, the penalty for going deeper is less than the penalty for going shallower. So I always err on the deeper side of things. Similar with corn, nodal root development. For beans, it is nodules. Those nodules need to set deeper in the seed trench as well. If we're up here towards the surface, what happens is it's warmer up there and there's less moisture. We're not going to be able to nodulate as well at the shallower planting depths as we would with the deeper planting depth. So that's really, really important with soybeans. Next up is seed firmers, and seed firmer is one of those things there's a lot of opinions about. I personally like seed firmers. I think most of the time they're doing a good job for us. This video here is from Ag Leader, and what we're doing here is watching beans come down that seed tube. Eventually you start to see the beans start to bounce off the floor of the trench and either be closed mid-trench or actually bounce all the way out of the trench. So firmers, number one, help us get seed clear to the bottom, but they're also going to help us keep seed in the trench. Money spent on seed or trying to make it grow, we've got to keep it in the trench. As far as yield data goes, long-term data here, multi-site locations, control with no seed firmer on the left at 208, about 4.5 bushel gain here with the Keaton seed firmer by using that to 213 bushel corn. Closing wheel adjustment plus data. So Tony talked about the maintenance adjustment, lining up your closing wheels and then setting your lateral spacing of your closing wheels per manufacturer's recommendations. Now let's talk about that pressure adjustment and the options that are available for closing wheels today. One thing I like to do at least once or twice a season, I usually do this when I change tillage programs or after a rain and maybe we haven't planted for a week. What I'm going to do is I'm going to come in here, we're going to dig perpendicular to the trench, then we're going to pull away from my digging tool and we'll expose what's going on. Let's watch this video. Okay, I'm going to show you how to quickly and easily check the performance of your closing wheels. Here's the tools that I utilize: a paint scraper or 2 of them, and this furrow digging tool from Precision Planting. You can get that one directly off the website. You don't have to have one of these, but it makes the job pretty easy. I'm going to take my paint scraper and we're going to place it into the soil in the trench perpendicular to the way we planted. And I'm going to use my other tool and we're going to pull away from that paint scraper. What that allows me to do here is when I pull that paint scraper out of the ground, it's going to show and expose the structure of how my closing wheel sewed together that trench. And what I can do here is I can keep prying back a little bit until I find a seed. So let's go ahead and excavate that trench. I'll show you what it looks like on the inside. So we're planting into fall strips here, some of the best planting conditions I've ever planted into. And by exposing our trench here like this, we can see exactly how that seed was covered up by the closing wheels. So in my trench, I do not want to see any air gaps around that seed. We want oxygen there. We don't want that soil compressed around the seed either. So we want to see enough oxygen there to where we can take it. We can kind of pry away from that seed a little bit. And it's got enough room and it's not compacted to where it's going to germinate very easily with good seed to soil contact. The only way you can see that structure from what we're showing here in the video is if you place something into the seed trench perpendicular and then pull away from it. If you dig from the top down, you ruin this structure, then you're not going to see what we've got here in this picture. The key is hopefully you can find a seed. Just keep shaving back a little bit as you've dug and you'll find a seed. If we see air around it, we've got to make an adjustment. If I can see my remnants of my seed trench and everything looks compressed, I've probably either got the wrong closing wheel, maybe solid rubbers, too much pressure, or I've got too much downforce. Back to locking your closing wheels up, getting out, looking and digging again. Or we get to the extreme here. From the top down, if you're walking above this, you would think that was closed and maybe you would move on and keep planting. By digging this method, you take a look and we see here that we've got a massive air gap above that seed. The likelihood of this seed making it is pretty slim. And this picture actually comes from our PFR site during the 2024 growing season. The other thing I notice is I still see my seed trench and that void right there. We might have too much sidewall compaction created by those gauge wheels. And then closing wheels at the wrong pressure probably don't have the ability to pull that trench out, bring it in, and then to surround the seed with soil. So we look at wheels here, and I like to keep the closing wheels as far as what we use on our planters. For you or for me on our farm, I do like to keep things relatively simple. There's a tons of options out there today. At the end of the day, here's my goal. Ultimately is better seed to soil contact. I do have to take that compaction out. A Deere, Kinsey, Precision Planter, they're going to add compaction. That's how we get to the depth. Case IH Planter, little bit different story on how they work. Eliminate those air pockets. At the end of the day, better, more uniform emergence by doing all this correctly. The wheels we're going to talk about as far as a simple form of testing with a traditional V-style closing wheel tail. These are the wheels that we've most recently tested. So you had our poly twisters on top, clear down the SI distributing finger wheels on the bottom, finger till wheels. Those are really different wheels when you're looking at them. I'm not going to place this SI wheel in the same scenario I would with the Yetter or even the Copperhead. They fit two different areas. For the Yetter poly twisters, over that testing time frame, they added about 5.1 bushel per acre. You take that times $5, $25 an acre for a closing wheel. 90% of the time, they're adding yield. We look at all these. They all have an excellent yield win percentage. They've all added bushels. If you're still running solid rubbers, I haven't ran into a situation through my career where solid rubbers are going to be the best choice. I think that's pretty rare. One of these wheels, more than likely, is going to be a better option than solid rubbers. Of course, there's many more out there than just these. My recommendation is if you're running solid rubbers or maybe even cast steel wheels, smooth wheels, I would try a row or two of something else. The SIs are going to fit pretty well in no-till and cover crops. The two over here with the Yetters and the Copperheads, they're pretty versatile. We come into beans. Pretty much the same thing here as far as a trend. They're all going to add yield when we compare them to a solid rubber closing wheel control. But look at the yield win percentages. 100%, 86, 100%, 100%. The Yetters, again, they're leading the pack. But that win ratio is awesome. It's almost a guarantee. If I had a $100 bill to give you, I'd almost give you that $100 bill guaranteeing you that one of these wheels here is going to outperform solid rubbers. When we look at the Case IH closing wheel assembly, of course it is different being two-stage, and I've had the question from time to time, you take them solid first stage wheels that come factory standard on a Case 2000 series planter, what about something like this? These are the Yetter 6000 shark tooth wheels. Those wheels are a flat planed spike wheel, basically what you see on a row cleaner. They're not concave like the factory smooth wheels. So they're not going to lift as much and they might be pretty aggressive. We're going to target those for tough planting conditions. Now when we look at this data set that happened in 2024, 3 locations in Indiana, the tillage program for those 3 locations was fall anhydrous ammonia applied at an angle and then planted straight, no tillage in between. The 3 fields right there from the 2.8 negative, 2.8 negative, and 3 positive is pretty variable. Now we go to the locations in Illinois. So 7 on-farm locations here. That tillage program was fall strips, no tillage in between, and then planted directly on top of those strips. Again, variable conditions right here. Overall, the trial gain for the Yetter shark tooth was a half a bushel loss. So I'm not going to stand up here today and recommend those wheels, but if you are in tough planting conditions yearly, I wouldn't be afraid of trying maybe a row of those and a row of something else, 2 or 3 options, giving them a try, following those rows throughout the season, and maybe seeing how they perform on a row-by-row basis. Lastly, when it comes to the planter omissions trial, when we start messing with our closing wheel pressure, it is really important to get that adjustment right. So if we take this closing wheel hook back off here, and we set our pressure, so the control here would have been in the second notch. So when we go from the second notch, to no pressure, that is the image that we see here from Kentucky. They simply didn't have the pressure in no-till to bring in the sidewalls and surround the seed with soil. Now, the other treatment would be second notch to fourth notch in conventional tillage. So our goal there was, hey, let's overdo it. Let's see what happens. When you take the average of those 2 scenarios, we're looking at a loss of $21 an acre, okay? It is big. For an adjustment that you make every field, you don't always know without digging the way that I've showed you how to dig, what's the right pressure to be at, okay? So I do challenge you to try to dig different this year behind your planter. It is really important. When we boil that whole planter omission study together here, incorrect downforce was the adjustment that had the lowest repercussions from. Planting depth had the highest. But every adjustment here is important. Downforce is related to planting depth and vice versa. So we want to make sure we're getting both of those correct, and maybe we're making those adjustments at the same time. Shutoff timing. No yield data here, but this is a critical topic to talk about. A couple reasons why. If you don't get your shutoff timing right, you're going to either overplant seed or underplant. And if you underplant, you're going to leave gaps. And if you leave gaps, maybe you've got a landlord that's testy and you're going to fight him all summer long about those gaps, or you've got weeds coming in. And it could be both of those. I spend a lot of time getting this right. I found this picture here on social media. If you're listening to this video and that's you, I apologize for bringing this up, but it's an excellent example, and I think people can learn from this. I'm going to read it. So this happened to me this year. I didn't realize my section control start and stop times were this far off. He names his planter and the tractor. Does anyone have on-off times that could get me at least in the ballpark? You can see these gaps from satellite images. No problem, okay? The other example is this one. This is a on-farm research trial I was setting up in Indiana for fungicide research. It made it awful easy for me to count my rows and set my flags because I knew exactly where that planter was. Take time and get your metrics set right for your shutoff values. Here's where they are. So I'm going to talk mostly about ag leader on top because we've got great definitions here. My auto swath function, this is the turn off look ahead. If I'm over planting, that's my problem. My recommended action is going to be increase the look ahead number. The result of that action is going to be the auto swath anticipates headlands sooner and turns the planter off sooner. Okay, so that's kind of how they work. Learn in your monitor where each setting for your shutoffs is located. So John Deere has called a mechanical delay on and off. Know what their values should be for starting value. They should be in your manual. The other thing with shutoff timing, if I go back here, let's say you've got a high-speed planter and you're going to plant normally on average 8 miles an hour. We want to be slowing down back here. We don't want to slow down as our front axle crosses our headlands, because then all of a sudden the planter thinks you're there, it's going to shut off too soon, and you're going to leave those gaps. So be very consistent on slowing down and speeding up coming out of those headlands. When I speed back up, that planter's got to be past my headlands before I start to speed up. Here's an easy way to check your shutoff timing as far as where the seeds are actually being dropped. So that's where that closing wheel hook is going to come back in again here. We're going to lift that wheels up and we're going to plant in and out of the headlands, and you won't have to dig seed this way. You can instantly see it. You can see if, oh, I planted 3 kernels or 4 kernels past my headlands, or I'm 4 or 5 kernels shy or a 10-foot shy. Gives you a really easy way to get that value set right. When I'm doing this, we're doing it at the normal speed that I'm going to slow down, make my turn, and speed back up once I've completed my turn. So we want to combine both of those methods together. Bulk fill. I do field a lot of calls every year about bulk fill. Bulk fill is one of them things that's hard for me to replicate those problems in the field, the exact problems you might be having with your planter if you're having those. I've taken the time and looked through manuals and figured out what planter make and model and what is the suggested normal lubricant for that bulk fill system. So for Kinsey 3000, that's going to be graphite at 1 bottle per 50 units. Lubricant B, so a lot of these manuals had a secondary lubricant that they recommended. I'm going to start with the first one. That's normally what I'm going to mix. If I have issues, I might rely on B. In this case, it's talc, okay? For a Kinsey 3000 and 4000. For a Kinsey 5000, graphite is A, 80/20 is B, okay? John Deere, all you see in a John Deere manual is talc. We're not going to run 80/20. We're going to run straight talc. It does say in the manuals to coat your discs in your meter with graphite, but as far as your lubricant in the tank, it's going to be talc. Case IH 1200, graphite or 50/50. The 2000 is going to be 50/50 only. That's a 50/50 blend. White 8,000, that would be your positive pressure planters. Talc, that's your rate, 1 gallon per hopper. The new Massey Ferguson's electric drive planters with the V-sets, they recommend 80-20, no lubricant B. Here's your bulk fill pressure on corn or your RPMs for the Case IH planters, and then the same for soybeans. That's a starting range, okay? That's not the exact number you might land on, but that is a starting range. Some really good settings here for Deere, and then again for Kinsey. Just showing that in the Kinsey 5000, it was graphite first, 80-20 second, and then actually talc third. But we're gonna start with graphite. I've went from 80-20 in my Kinsey planter to graphite, and I've had less bulk fill issues when I've ran straight graphite. As far as tips and the adjustments you can make with your bulk fill system, here's kind of how I start if I'm having issues. Check your seals. If we're not sealing on top of these boxes, we're blowing pressure in basically, and that pressure's got a hold in the tank. If my lid is leaking by, we don't have enough pressure to get the seed out to the units or even move it within the tank. Hose maintenance. If you take your hose off your mini hopper and you look inside your hose and it's full of debris, we need to get those hoses cleaned out. It's like your arteries in your body. We don't want your arteries to be plugged. That's the arteries to get the seed from the tank to the meter. Loading. So if you're loading your planter and you're going from let's just say a 40-pound seed to a 65-pound seed, I'm not going to load that planter plumb full. Because if I have issues, we've got a full planter, and then we've got to deal with that problem. The other thing is, if I do have issues with the big seed, and I need to return it, exchange it for something else, it's already in the planter, and they're not wanting to take that as a return more than likely. So I'm going to take that very slow, probably 2 bags per side, plant a little bit, make sure it's going to work. Pressure adjustments, we want to start that gradually. So this goes with your vacuum, on your planter, or your bulk fill even. When you start it, have your tractor in idle. Don't have your RPMs up. And then when you shut it down, we're going to put it in flow so it stops slowly. It's not a hard stop. You'll eventually blow your seals out if you keep hard stopping your vacuums. So we're going to start it gradually. We're going to increase the pressure 1 pound at a time until all rows plant at the correct population. The outside rows will receive seed last. Starting the fan too quickly may cause seed bridging at the meter or at the manifold. When it comes to those lubricants we talked about, we want to mix those as thoroughly as we possibly can. Graphite is naturally going to sift through the seeds, but 80-20 and talc require manual mixing. So here's how I do it. I'll dump a little bit into my bulk tank first, 2 bags, and then some graphite. 2 bags, and then some graphite until I've got my seed in there and I'm full. If I feel I need to mix it, I'll take a broomstick and we will do our best to mix that. If you have a tender, a graphite inductor on a tender is an excellent investment. So it'll help you with your lubricant and seed mixing, and you'll have a consistent mix inside your planter box. Let's say we have issues. Okay, here's how I troubleshoot. If seeds aren't flowing, detach the hose from the mini hopper. Okay, if I've got high airflow at this end of the hose, more than likely I'm bridged up at the tank. And a bridge means I've got a gap between my manifold floor and the seed itself. We've got to knock out that bridge, take a broomstick, knock it out, try again. Low airflow, so I'm not getting much air out of here, means the other end of the hose is plugged. So we want to take the other end of the hose off, locate that plug, clear it, but I also want to check the lubricant on the seeds. If it doesn't have any lubricant coating, that is probably part of my problem. Now, if I've got high airflow with seeds flowing when I pull this off, the meter is most likely plugged probably at the baffle or at the elbow. Okay, so we want to take a look, take things apart here and see where that plug is actually happening. If it's persistent, and I cannot get the plugging or bridging to stop, you can add up to 2x rate of the lubricant, and that is in the manuals. You can do that. I wouldn't recommend it all the time, but you can, in fact, do that. Moisture, let's say it's 60 degrees in here, and it's 80 degrees outside. You pull the seed out, your seed's gonna sweat. We're not gonna put it directly in the planter. We're going to let it go through that process, and then once it's dry, we'll pop it in the planter. If you're planting and you get rained out, and some odd reason you get condensation in your tank, you can try this. Opening up your lids and running your bulk fill fan, trying to get the moisture out of those tanks. If you don't know if your seed has gained moisture, grab a handful. If it stays in a light clump, you've gained moisture, okay? One thing to remember here, graphite is for lubricant and talc is for removing moisture. So for you Kinsey planters that are using straight graphite, a little bit of talc, if you've got moisture, might help you. One more thing. This is directly from John Deere's XP planter manual. I'm going to read the majority of what's in the green. The CCS system performs best when using the lowest possible pressure setting to reliably deliver seed to all row units. There will be very little seed flowing in the delivery hoses when operating at optimum performance. The system will run lean. If the system pressure is too low, the nozzles will not pick up enough seed. Increasing the CCS pressure will help nozzles pick up seed aggressively. It may begin to collect in the delivery hoses, which can lead to system plugging. In general, increasing CCS pressure too much will contribute to delivery hose plugging and hopper elbow plugging. It's telling you the system should run lean. Start low and slow and plant while you're increasing your pressure a little bit at a time until all row units are planting at your target pop. We're going to want to do that step. If we've got big seed, maybe we've got a couple bulk fill issues, those problems are going to compound with each other. If you're having other problems and that document doesn't help you, here's a document from John Deere. The QR code is right there. That'll get you to this document, and it's going to help you walk through maybe a little bit deeper than I have here in this presentation. Same goes for Case IH. 1200 series on the left, 2000 series on the right. They've got a nice troubleshooting diagram, the step 1 through whatever that bottom step is to get you set up and planting again. Lastly here, there's 2 planters that I have found that have bulk fill updates. Kinsey, early 3000 series and early 4000 series have the original designed entrainer here on the right. You can update to the 05 series design and you can get those parts from your dealer. My 3660 at home has the original. I might have one problem every other year with bulk fill. I'm very patient with it and I take my time. For Case IH planters, if you have a 1200 series planter, here's the Case IH 1200 series bulk fill enhancement kit. A few parts that help you at the meter end of the system. Final tips on bulk fill. If needed, make those 2 updates. If you've got either of those planters, if you feel you need to, start your pressure slow, mix your lubricant with your seed, allow your seed to warm slowly. If seed bridges at high pressure but you can't keep up at low pressure, plant slower. Read your owner's manual. That's a very helpful guide. Keep it in your tractor. So you even save it on your phone if you would like. Talc replacement and additive products. Proceed with caution. A lot of those are PFR proven, and a lot of those add some really good yields to your bottom line. However, they were not tested in a bulk fill planter. Okay, so I want you to proceed with caution on that. I do recommend some of those products, but we're not going to buy a pallet worth and hope that we don't have bulk fill issues with them. Lastly is patience. I know we're in the heat of the moment. I know we're trying to get things done. But when we're maybe mad at the seed or mad at the planter, and we can go through these steps and probably fix it, most of the time these steps are going to get you fixed. I'm not saying there's not a seed size the planter won't plant. It could be the seed's fault. It might also be the meter or the bulk fill system's problem, or a combination of everything. Planter drive improvements. Another area that we don't have any data for, but I find this interesting. I get told all the time how simple a ground drive planter is. In my area, when clutches came out, it made a ground drive planter a lot more complicated. So you got your transmission, your row unit chain, your air clutch in this example, plus your compressor. So you've got 4 systems right there. An electric drive is going to do the job of all those. Same goes for the hydraulic drive systems. There's my hydraulic drive motor, my row unit chain, and my electric clutch. 3 systems. You get rid of all those bearings, all those systems together, and we can go to 1. Okay, I've ran electric drives for a long time. Haven't had many problems with them. I've had 1 harness issue and 1 motor go bad in 10 years. If you've thought about this, maybe you're on the fence, I think they're worth it because they do multiple jobs with 1 system. High-speed planting. So in 2014, I was at Precision Planting's winter conference, and they were getting ready to unveil high-speed planting with speed tube in 2014 to the farmers in the room. I didn't believe that we would be able to plant at 10 mile an hour or even 8 mile an hour and do a good job. But from then on, we hook it up and we speed up, okay? So I've had a lot of fun testing the high-speed systems. We've actually tested all 3 of those. We're going to walk through those systems one at a time here, showing you how they work. Here's Precision Planting speed tube. We're going to utilize a V-set meter here. Counter-rotating wheels are going to pull that seed off of the disc and then transition it to the belt. The belt's going to drive that seed down to the bottom at the speed we're planting. It then will be a dead drop with no bounce. We move on to John Deere's Exact Emerge system. And it utilizes a brush belt instead of a cleated belt. My sensor's on the front edge of that belt system. We come into that bowl meter here. Here's my singulator knocking those doubles off. Then no transition device. It goes directly from the disc to the brush belt, and it's going to carry it down to the bottom of the trench. Very simple design, works very well. Lastly, we've got Ag Leader Sure Speed or Kinsey True Speed. The mechanical components of those 2 systems are identical. The electrical components and maybe the motors are different. We tested the Ag Leader Sure Speed system through our PFR research. The meter sits in there perpendicular to the row unit and the tube. We'll bring that seed from the bottom of the seed pull to the top. Here's my no adjust brush singulator going to knock off those doubles. Bring it around to a brush wheel. And this is my transition device. It's going to transition the seed from the disc to the belt. There's that brush wheel making that transition. And then we're also going to move that seed down to the bottom of the trench at a very low exit point in the trench at a dead drop. When we look at yield results from the 3 systems, we tested speed tube first. Speed tube is the only system that you can run with either a speed tube or a conventional seed tube with the same meter. The Ag Leader and the John Deere systems, you have to run the high-speed tube system with those meters. So with speed tube, on the far left, I've got standard seed tube at 5 miles an hour at 195.4 bushel to the acre. When I plant same 5 miles an hour with that speed tube installed, I gain almost a bushel. So there is a placement advantage to the HighSpeed system in that scenario. And that is PFR proven, by the way. Then we've got 7.5 mile an hour with the dark gray bars, came in at 195.4. The same as 5 mile an hour with a conventional tube. And then at 10 mile an hour, 194.7. Statistically, not much less. With the exact emerge system, 5 mile an hour with that system, 250.2. 7.5, 253.1. Actually a yield gain when we sped up. And then 250.3 at 10 mile an hour. Statistically not a yield gain, but it wasn't less. Both 7.5 and 10 mile an hour are PFR proven with the exact emerge system. And then we've got the Ag Leader Sure Speed system. Dark green again is 5 miles an hour. 7.5 is 234. Same as 5 mile an hour. And then at 10 mile an hour, 234.9. Both of those again, PFR proven. So the John Deere Exact Emerge and the Ag Leader Sure Speed were both tested in various tillage programs in multiple fields for 3 years worth of testing. This is data that I can rely on to plant faster. However, we're going to make sure everything Tony and I talked about today has got to be up to an A+ standard. We can't just plant 10 mile an hour and forget about our adjustments. We've got to make sure we're doing things right. Here's what I wouldn't do. John Deere Max Emerge 2 or earlier, I'm not going to run for high speed. The shank's not going to handle it. Kinsey 2600 and earlier, same thing. Case IH 1250 and earlier, probably should stay away from those. And same with the White 8000 and earlier. There's a lot more shock and impact planting at 10 mile an hour or even 8 than there is at 5. Ultimately, the goal for me for high-speed planting is covering acres at a targeted planting date window that I know is probably my best advantage for my most highest yield potential, but also avoiding marginal planting conditions. I shouldn't have to plant in marginal conditions anymore because I'll pick up speed. In my area where I'm from, it's hard for us to plant some of our fields with a 24-row planter. So a 16 works good. But on our bigger fields, speeding up, we can gain some efficiency, and that's where high-speed planting came in for our operation. No-till coulters. If you're still running no-till coulters, you might have a reason. My dad says that seed disc openers last longer if he's got coulters on. He's probably right. However, we start to look at our data here. 2 years. No-till coulter versus speed. Here's my treatments. I've learned so far that it has taken 25.5 pounds more applied downforce to keep them row units at my intended downforce setting when the coulters are installed. When we look at the yield data here, 5 miles an hour with the coulter installed, 239.5. Coulter removed, 240. I gained 0.9 bushels. 10 miles an hour, coulter installed, 240. Coulter removed, 10 mile an hour, 242, 1.5 bushel gain. We had slight yield increases with the coulter removed. Once our coulters are worn out on our planter, we're not going to put new ones on it. We're going to walk away from those. If you're concerned about it, I would try removing a couple rows and just testing on your own. I don't think they're doing a lot for us minus saving our openers. Lastly, new planter decisions. I do get these questions from time to time. If I was to buy a new planter, what would I choose? Looking at the 6 up here, we've got Precision Planting Ready Row Unit. That would also be the same as a Massey Ferguson 9000 series row unit. John Deere Exact Emerge with the ME5 row unit. Precision Planting Cornerstone, that's their latest. Case IH 2000 series row unit. Horsch, and then Kinsey 5000 series row unit. Of the 6 that are up there, 2 are quite a bit different. We've got Cornerstone that's got the following gauge wheels and furrow force at the back, 2-stage closing wheel system. And then we've got the Case IH 2000 series row unit. We all know that that row unit is vastly different than everything else that is up there. Assuming the others are all high speed, what does it come down to for me to make a decision? If I was to buy a new or a lightly used planner. Here's how I kind of thought about that decision if I was to make one. Budget. We all know that. Price, used versus new. There's a lot of excellent used planners out there today that have a lot of excellent technology, durability, serviced, and wear parts. Okay? For me, service is big as far as me servicing it. How well can I service it? Or maybe you have a dealer service your planner every year, or a planner precision ag company that might take care of it for you. How easy is it for them to do and how quick? Resale value, obviously for all those. Technology, the monitor experience, record keeping, and cloud transfer. How easy is that? How easy is it to learn? How easy is it for you to teach your operators how to use? Relationships, we all know that one's important. Here's one. Planner to tractor specs, hydraulic flow, number of remotes needed, etc. Attachments. What does it come with out of the factory if I was to buy a new one? What closing wheels, row cleaners, downforce system, meters, high-speed options, and then your frame options, weight transfer, bulk fill tracks, tire inflation kits. In my opinion, nobody makes a bad planner today. On my farm, we just made a new planner decision. We went from a 16 32 row splitter and an 8 16 splitter. We always ran the same crop for both planters at the same time. It got hard on years where you were pressured with planting date windows, getting things done in a timely fashion with each crop. There were times where we would be planting corn. We should have been planting beans, but we didn't want to take the time to switch the planters over. Here's how I made the decision. 2 things up here. Durability, service, and wear parts. I don't mind working on corn planters. However, I don't want to keep putting money into wear parts every single year to keep that planter in tip-top shape. Technology, I can handle that part just fine through my job training. But then tractor to planter specs. So when we traded the 8-row planter off, we wanted to use the same tractor on a 16-row, 30-inch planter. I don't have the hydraulic flow or the number of remotes to run certain planters. I was on the fence between a John Deere machine and a Kinsey. The Kinsey allowed me to trade and only use a tractor that's got 3 remotes because it runs with a PTO pump. John Deere, and I wanted high speed, and I wanted hydraulic downforce. John Deere planter didn't have the ability to run with a PTO pump. So I'm going to have a problem with my hydraulic flow number of remotes. We didn't want to trade tractors. So we did end up going with the Kinsey 5000 series planter for this upcoming season. I do feel it's got some features on it that I like. It's got a pin adjust closing wheel that I can actually unpin and rotate my closing wheels up and out of the way so I don't have to use a closing wheel hook anymore. We've seen the gauge wheel earlier and the gauge wheel arms, but then it's got double bushing parallel arms. So I've already got what I want. I don't have to worry about it later on down the road. 3 years down the road from now, we're not going to put $1,000 in it, per row. We're in pretty good shape. So that's why I chose going that route. For you, it might be a Case IH planner. For me, I've got to go a long ways to get to a Case IH dealership. Or it might be a Deere for you, or a Horse, or something else. So that's kind of how I made my decision. If I could sum up this clinic in one acronym, what would it be? GOLD. Get out, look, and dig. I feel you make the most money by doing this step for many of your planner adjustments. The QR codes that are up here on this final slide are the QR codes for all the documents we talked about, Couple added documents here. We've got a planter resource guide. It's got maintenance specifics in it by brand, and it's also got some of our yield data we did not talk about today. Here is the QR code for the whole presentation we just talked about and covered. Productivity guides for Case IH planters, John Deere bulk fill troubleshooting guide, and then the all-important indexing your planter video. I do want to thank you for your time. I hope you have an excellent planting season and growing season here coming up this year. Thank you.